Hey everybody, it's the start of chapter 8.4, Area of Triangles. Okay, so like normal, here's our objective. Today we're going to be talking about finding the area of triangles, something I know you have done in the past. So please write this down, pause if you need to, and I will explain. It says area of a triangle. In words, when you take the area of a triangle is equal to half times the base times height. Okay, and when you look at the height of a triangle, you're looking at the perpendicular segment from which the vertex to the line containing the opposite side. In other words, you're looking at this perpendicular segment. You know it's perpendicular because you have that 90-degree angle, and it's perpendicular to the base. Okay, and your base is going to be that opposite side. So here's your height, here's your base. In order for you to find the area, you have to take half of that. The reason why we take half of that is because if we did the full, it's just like finding the area of a quadrilateral. Okay, so what we're going to do, write this down and try to figure out if you know how to find the area of these triangles. Finding the area of the triangles. Looking here, again, you're going to use that same formula we just found out. It's going to be area equals half times base times height. Okay, we know that the height is going to be that perpendicular segment right here. Okay, that's perpendicular to the base angle. Okay, so you're going to have half times 7 times 12. When you multiply these straight across, you come up with your answer of 42. But don't forget, you're also multiplying centimeters times centimeters. Okay, so your answer is going to be 42 centimeters squared. All area is going to have a squared unit. Just like it was for the area of quadrilaterals, same thing with area of triangles, squared unit. Okay, again, plugging this into your area formula, looking at area equals half times base times your height. Okay, in this type of a triangle, your height is going to be right here, and you're going to plug that into your equation, times 7 times 4. When all is said and done, you multiply this straight across, you come up with 14 yards squared. Don't forget squared units for your answer. All right, very nice. Moving on to the next one. This says find the missing measures. All right, so we know right away we have our area right up here. Okay, and then this 15 centimeters, is that going to be the height or is that going to be the base? You are correct. That is going to be our base. So knowing our area is 120 centimeters, knowing our base is 15 centimeters, plug that into the equation that we know and solve. All right, take a moment, pause, try to see if you can find what h is. Okay, our equation again, a is equal to half times base times height. Okay, we're using that same idea. Okay, even though this height is on the outside of our triangle being right here, I know our height is on the outside, but that doesn't change your formula. You still use that same formula. All right, so area, we know what our area is. It is 120 centimeters squared is equal to, our half is our constant, which means that stays there. We know our base is our 15, and our height is going to remain as h. All right, so the very first thing that you're going to do is, I always like to multiply this straight across. 120 is equal to 7.5h. When you divide by 7.5 on each side, you are going to get h is equal to, what is it going to be? Absolutely, that is going to be 16 centimeters. Remember, we're finding our height, not our area, our height. So our unit is going to stay as a singular unit. Nice job. Okay, so please write this down. Take a moment to pause, and we'll go over it in just a second. It says this is going to be a postulate or a theorem. I apologize. A theorem that deals with the areas of similar polygons. Okay, if you take two polygons, okay, if they are similar with a scale factor of a over b, we talked about scale factors before. If it has a scale factor of a over b, then the ratio of their areas is a squared over b squared. Okay, so in other words, if you look at that polygon ABCD is similar, and we know that's similar is because it has that wonderful similarity symbol. ABCD is similar to polygon EFGH with a scale factor. Okay, and our scale factor, I did not put this in. Our scale factor of A over B. Okay, then, whoop, that is not supposed to go there. It's supposed to go here. There we go. Scale factor of A over B, then the area of ABCD over the area of EFGH is A squared over B squared. Now, what in the world does that mean? Okay, the very first thing is you need to find the scale factor, and then what you're going to do is you're just going to square the top and the bottom number, your numerator and the denominator. So let's try one. Looking at this problem here, it says find the scale factor of triangle ABC to triangle DEF. Then find the ratio of their areas. Okay, this is going to be the key piece of information. Whoops. Right here of triangle ABC to triangle DEF. What that does is that tells you exactly which one is your numerator, which one is your denominator. So pay attention to that as you're finishing this problem. Pause now, give it a shot, see if you can figure it out. Okay, so I am going to find the ratio of ABC to DEF. In order for me to do that, I need to find two similar things. I'm going to look at my two heights. Okay, I have ABC, the height of ABC is 6, to the height of DEF, which is 8. Again, notice when I look at this, okay, I needed to focus on ABC to DEF. I could not take 6 over 9. The reason why I don't take 6 over 9 is because I want to find that scale factor of ABC to DEF. Alright, so I don't take 6 over 9 because that is the height and base of ABC. I'm focusing on that ratio. So what your answer is going to be, you're going to come up with, divide by 2, you get 3/4. Again, I'm going to use my base this time. Okay, my base is going to be 9 over 12. Remember, I use my base of 9 on ABC and my base of 12 on DEF. Notice again, my ratio is ABC. Okay, ABC over DEF. I need to keep that ratio. I cannot take height over base or base over height. I need to take the ratio of ABC to the ratio of DEF. Alright, so moving along, divide both sides by 3, I get 3/4 again. Now that I've found the scale factor of ABC to DEF, remember that equation, once you find A over B, the ratio of their areas is A squared over B squared. So their area of their ratio, or the ratio of their areas, you take 3/4 and square both the top and the bottom, and you come up with 9/16. So 9/16 is going to be your ratio of the area. 3/4 is going to be your scale factor, and I can toss that in right there to help you visualize that one last time. Okay, so this lesson is all about your area of the triangles. There's going to be a couple of problems on your homework that's going to deal with polygons and triangles. Okay, or sorry, not polygons and triangles, quadrilaterals and triangles as far as squares and rectangles built in with that triangle area and finding the area of the overall shape. All right, good luck. I know you'll do great.